Hello, and thank you for joining me today as we continue discussing stoichiometry and different calculations that go along with it. Yesterday we learned about molar ratios, or last time we met we learned about molar ratios and converting between moles of a substance. Today we're going to expand that, and so our goals for today are for you to be able to use your knowledge of stoichiometry to convert between moles of substance A and grams of substance B, or vice versa. So let's kind of jump right in and we'll see how this goes. So, and this is kind of why we do this. So my first question is, how much is 0.273 moles of copper? Could you tell me that kind of right offhand? My guess is you probably couldn't, because I couldn't tell you that. So balances don't tell us moles. That doesn't do us a lot of good, but it gives us this thing called mass. We measure things in grams. And so we can take a known mass and calculate an unknown number of moles, or a known number of moles and calculate an unknown mass value. So this is called mass to mole and mole to mass calculations. And so let's start right here. So you are asked to calculate the mass using grams of a substance that will react or be produced from a specific number of moles of a second substance. So we're taking moles of substance A, converting to moles of substance B, and then to mass, or the grams of substance B. So what I'm going to encourage you to do, in my class I talk about mole mountain a lot. So we're going to draw mole mountain twice. So we have moles of substance A and moles of substance B. Now, mole mountain goes from moles into grams or mass, or we can go into atoms or molecules. Okay, same thing on substance B. I can go to grams of substance B, or I can go to atoms or molecules of substance B. Okay, so now we're starting at moles of A, and we have to get to grams of B. So to do that, think of these as a mountain. I like the mountain idea because when we're talking about humans in everyday life, when you climb a mountain, you get to the top and you realize that you look off in the distance and, oh, there's another mountain that's a little bit higher. So in order to get there, you have to go from the bottom of mountain A all the way, or from the top of mountain A all the way down to the bottom, and then across and over to mountain B. With chemistry, with stoichiometry, we can shortcut that. And so imagine like this super highway that goes from moles of A to moles of B. So you go from the top of mountain A to the top of mountain B. And we can convert this using our molar ratio, or a mole ratio, which we talked about in the last video. Okay, and so we're going to go from moles of A to moles of B using our mole ratio, and moles of B down to grams using our molar mass. And so this is what's going to happen. So you go from moles of A, and there's our ratio, moles of A to moles of B, and then we can go from moles of B to the mass of B using our molar mass. And so that's what we're going to practice with today. But this concept, this idea, we're going to use a lot in this unit and throughout the semester. Okay, so some steps for solving. Step one is obviously to write the balanced equation. This is super important. We have to write the balanced equation correctly, or the rest of it falls apart. Determine what you need to find and what you know. Find your conversion factors, and then solve and round to significant figures. For example, plants use carbon dioxide and water to form glucose, which is C6H12O6, and oxygen. What mass in grams of glucose is produced when 3.00 moles of water react with carbon dioxide? So step one, carbon dioxide, CO2, and water, H2O, react to form glucose, C6H12O6, and oxygen, O2. What mass in grams of glucose, so I need mass equals, I don't know, is produced when 3.00 moles of water, 3.00 moles of water react with carbon dioxide. So step one, we have the equation, we need to balance it. So I know there's going to be 6 here, I know there's going to be 6 here, I know there's going to be 6 here. So make sure we can balance that correctly. Now, we have to go from moles of hydrogen or moles of water to grams of glucose. So we're going to start with what we know, which is 3.00 moles of H2O. I'm going to draw a mole mountain again just so you see it and we have this visual. So we go from moles of A to moles of B, and we have grams of B, we have atoms or molecules of B. Atoms is shorter to write, so I'm going to stick with that one. We have atoms of A and we have grams of A, or mass of A. Okay? So now, we're starting in moles, so we're starting here. We're trying to get to grams of a different substance. So we have to go all the way down, we have to get to grams of B. So to do that, we're going to go from moles of A to moles of B. We do that with our molar ratio. So we have 3.00 moles of water. I'm trying to get to glucose. So my ratio, I have 6 moles of water here. 6 mole H2O, and I have 1 mole of C6H12O6 on top. So I've gone from moles of A to moles of B. Now, from moles of B to grams, I need to know that 1 mole of C6H12O6 has a molar mass of 180.16 grams of C6H12O6. So now I can look, and I've crossed off moles of water with moles of water, moles of glucose with moles of glucose. I'm left with grams. So I can multiply all of this, and I should come to a final answer of 90.08. Oops, undo that quick. Should get 90.08, and with sig figs I need 3, so 90.1 grams of C6H12O6. That's going to be my answer there. Okay, that's going from moles of substance A to grams of substance B. Here's a question for you to practice. Pause the video, work through this. The answer's on the next slide. So hit pause, and then when you hit play, you'll get your answer. And your answer should be 283 grams of aluminum is how many grams of aluminum I need to produce 5.25 moles of aluminum oxide. Okay, now we can do the opposite. We can go from grams of something to moles of a different substance. So here we have potassium chlorate breaking down into potassium chloride plus oxygen. So if I start with 25 grams of potassium chlorate, how many moles of oxygen gas will be produced? And so here we go. I'm starting with 25 grams of KClO3. I have to get to moles of oxygen. So again, we're going from moles of A to, oops, I have grams on one side, I have atoms on the other. It should be molecules, but atoms and molecules in this regard are the same. Moles of B, grams of B, oops, this should be atoms of A, sorry. I rushed through it. Grams of B and atoms, again, of B. So I have 25 grams of potassium chlorate. So I need to go from grams of A all the way to moles of B. So step 1, go from grams to moles. To do that, I need to divide by my molar mass. And molar mass of potassium chlorate is going to be 122.55 grams of KClO3 per 1 mole of KClO3. And then my molar, my ratio. So again, I should balance this first. Oops, boo-booed there. If we balance quick, my moles of potassium chloride should have 2 on bottom. I should have 3 moles of oxygen on top. And if I divide all this out, 25 times 3 is 75, divided by 122.55, divided by 2, I should come to a final answer of 0.31 moles of oxygen. And that hits my significant figures. Should be good there. Okay. I have a practice problem for you on the next slide, and then we'll wrap things up for today. So here we go. Sodium reacts with magnesium fluoride to produce magnesium and sodium fluoride. If you react 2.645 moles of sodium, how many grams of magnesium fluoride are needed? So step 1, write your balanced equation. Step 2, go ahead and solve. Go ahead and pause it here. When you hit resume, I'll give you the answers, and we can continue our discussion and finish things up. Okay, so here, if you calculate 2.645 moles of sodium reacting, you should produce 82.39 grams of magnesium fluoride. So make sure you can work through and get that same answer, and if so, then we're off to a good start, and we'll continue things and pick things up tomorrow. Here's some closure questions for you, so make sure you can answer these. So I want to know, how do you convert from moles of a substance to grams of the same substance? And then what if I wanted to go from moles of substance A to grams of substance B? How would I do this? And make sure you can answer that, and then we will pick things up next time. But thank you very much for your time and attention. I look forward to continuing this journey with you through chemistry, and I will see you next time. Have a great day.